There is a building in Rome with a hole in its roof, and it has been standing for 1900 years. No steel inside it, no modern engineering. It still holds the record for the largest dome of its kind on Earth, and nobody has beaten it since it was built. Meanwhile, a motorway bridge poured in the 1970s is often considered near the end of its life. Car parks built in your lifetime are being demolished because they are crumbling. We have satellites, supercomputers, and materials science. The Romans had slaves, hand tools, and volcanic dust. So why is their concrete still there, and ours is not? That question is not rhetorical. For over 1,000 years, we genuinely could not answer it, and we genuinely could not copy it. Welcome back to TokiCast, my friend. If a story like this is your kind of thing, follow along. It means everything to us. Let me start with what concrete actually is, because almost nobody knows. Concrete is not a material you dig up. It is a recipe. You take a binder, which is a powder that will chemically set when wet. You take aggregate, which is stones and sand doing the actual load bearing. You add water, and the binder undergoes a chemical reaction and locks everything together into artificial stone. That is the trick. Concrete is liquid rock. You can pour it into any shape you can build a mold for, and then it becomes permanent. Before concrete, if you wanted a building, you cut stone to shape, or you fired bricks, and you stacked them. Every curve, every arch, every dome had to be assembled piece by skilled hands. Concrete meant you could pour a shape. The Romans understood this better than anyone would again for a very long time, and their recipe had one ingredient that changed everything: volcanic ash. Around the Bay of Naples, near a town called Pozzuoli, there were deposits of a particular volcanic ash. When Roman builders mixed that ash with lime and water, the result set into something far harder and far more durable than lime mortar alone. They knew it worked. They wrote about it. A Roman architect named Vitruvius described the mixture and where to get the ash. What they could not know was why. Because the chemistry involved would not be understood for almost 2,000 years, and they used it everywhere. Aqueducts, bathhouses, harbors, roads, and the Pantheon finished around the 2nd century with a dome roughly 43 meters across, made of unreinforced concrete, with an open hole at the top and no steel anywhere in it. It is still the largest unreinforced concrete dome in the world. And the scale of what they poured is easy to underestimate. Roman concrete was not reserved for showpieces. It was infrastructure. The vaults under the Colosseum, the great bath complexes that could hold thousands of people, aqueduct channels running for tens of miles, breakwaters and piers in busy commercial harbors. This was a civilization that had worked out how to manufacture stone in any shape it wanted, and then used that ability on an industrial scale for ordinary public works across an empire. And crucially, they poured it with unskilled labor. You do not need a master mason to fill a wooden mold. You need someone to mix and someone to carry. That is what made it transformative. It was not merely a better material. It was a material that could be used by anyone, quickly, in enormous quantity, which is exactly why its disappearance mattered so much. Europe did not just lose a recipe, it lost the ability to build large permanent structures without skilled stonemasons, and it would take a very long time to get that back. Then Rome fell, and here is the part that always stops me. The recipe went with it. Not stolen, not destroyed, it simply stopped being used, and then stopped being known. The building programs that needed it collapsed, the trade networks that moved the ash broke apart, and within a few generations, the knowledge of how to make good hydraulic concrete drained out of Europe. For over 1,000 years, people walked past Roman concrete structures that were still standing, still in use, and could not make anything like them. Think about that. The evidence was right there. In some cases, people were living inside it. And it still took until the 1700s and 1800s for engineers to work their way back to a usable modern cement. So now we have modern concrete, and it is extraordinary. It is the second most used substance on the planet after water. Every city you have ever seen is made of it. And this is where the story appears to resolve. The answer looks obvious. Roman concrete lasted because it had that special volcanic ash, and we do not build with volcanic ash. Mystery solved. That is what I believed too, and it is not right. Because it does not explain the strangest Roman structures of all, their harbor walls. The Romans poured concrete directly into seawater. Now, seawater is one of the most destructive environments there is for modern concrete. Salt attacks it relentlessly. Marine structures are a constant maintenance problem. Roman marine concrete did not just survive the sea. Studies have found that seawater reacting with the volcanic material actually caused new interlocking mineral crystals to grow inside the concrete over time. Their harbor walls did not slowly weaken in the water. They kept strengthening. And even that does not explain everything. Because for a long time, researchers assumed the small white lumps found throughout Roman concrete were sloppy mixing, poor quality control, bits of lime that never got properly blended. More recent work has argued the opposite. Those lumps, sometimes called lime clasts, may be deliberate, produced by mixing at high temperature. And here is what they appear to do. When a crack forms in the concrete and water gets in, the water reaches one of these lumps and reacts with it. That reaction produces new material that fills the crack. The concrete heals itself. So the small white flaws that we dismissed as Roman carelessness for decades may be the reason the structures are still standing while ours are not. That is the actual answer, and it has almost nothing to do with what I assumed. The Romans were not just using better ingredients. They were building material that repairs its own damage. But if their concrete is so much better, why do we not simply switch back? And the honest answer is uncomfortable. Because modern concrete is not trying to do the same job. Roman concrete is strong when you push on it, and weak when you pull on it. So Roman buildings are thick, heavy, and shaped as arches and domes, because those shapes push loads downward into the ground. Modern concrete is poured around steel bars. Steel is superb at handling pulling forces. That combination lets us build thin, flat floors, long, flat bridges, cantilevers, and towers, shapes that no Roman could have attempted. We did not get worse at concrete. We made a trade. We took a material that lasts and made it able to do things it could not do before. And the price of that trade is the steel itself. Because if water and salt ever reach those steel bars, the steel rusts, and rust takes up more room than the metal it came from. It swells inside the concrete and cracks it open from within. Every piece of reinforced concrete on Earth is quietly counting down to that moment. The Pantheon has no steel in it. That is precisely why it is still there. There is a number attached to modern concrete that puts all of this in perspective. Producing cement, the binder in modern concrete, requires heating limestone to extremely high temperatures, and that process releases carbon dioxide both from the fuel and from the limestone itself. Cement production is commonly estimated to account for something in the region of 8% of global carbon dioxide emissions, which means the material we chose because it is versatile and which will need replacing within decades is also one of the largest single sources of emissions on the planet. Roman concrete, by contrast, used lime and volcanic ash and did not require the same extreme temperatures. That is one reason researchers are so interested in the old recipe now, not as archaeology, as engineering. If a modern concrete could heal its own cracks and double its service life, the environmental arithmetic would change substantially. The Pantheon is not only a monument, it is, quietly, a research paper we have not finished reading. So that is the real answer to the question I asked at the start. Roman concrete does not survive because of one magic ingredient. It survives because it heals its own cracks, because seawater makes it stronger rather than weaker, and above all, because there is no steel inside it waiting to rust. Ours crumbles not because we are worse builders, but because we deliberately chose flexibility over permanence, and put a corroding metal inside our buildings in order to get it. We began under a dome with a hole in it that no one has surpassed in 19 centuries. We learned that concrete is a recipe, not a rock. We stood in the ash fields near Naples. We watched the recipe vanish for 1,000 years, while the buildings it made stayed standing in plain sight. We found harbor walls that grew stronger in the sea, and white flaws that turned out to be a healing system. And we discovered that the weakness in our own version is the very thing that makes it useful. And here is the quiet part, the part that is really about you. What I keep returning to is the 1,000 years. The knowledge was not hidden. Nobody burned it. The proof of it was standing in the middle of European cities the entire time, being used as churches and markets and homes. People sheltered inside the answer while being unable to reproduce it. Knowledge is not safe simply because it once existed. It survives only as long as somebody is still practicing it. The moment a skill stops being used, it starts to disappear, and the objects it made will outlive the ability to make them. That is worth remembering about the things you know how to do, not the facts you can look up. The things your hands or your judgment know, that you learn slowly, and that nobody has written down. Those are Roman concrete, impressive while they last, gone the moment the last person stops practicing. Now tell me, which part surprised you the most? The dome nobody has beaten in 1900 years, the harbor walls that grow stronger in seawater, or the white flaws that turned out to be self-repair? Tell me below. Next time. Every one of them you have ever eaten is a clone, not a relative, a clone. And the one your grandparents ate was a completely different thing, wiped out by a disease that is now coming for its replacement. Take care of yourself, my friend. This has been TokiCast, where the small things quietly change the world. I'll see you soon.